So today we are going to learn about what is the fundamental makeup of matter. Okay, what does matter made of? Yeah, what is matter made of? So, for example, if I ask you, uh, what is a cup of coffee is made out of what? A cup of coffee for morning coffee is made out of what? So, sa naman halo coffee.
Sugar,
Coffee,
Yeah, you have
sugar,
sugar, obviously, coffee.
milk,
What
egg,
or
else?
water.
water.
Water, and then milk. Some people put milk on it, right?
Yeah.
Yes.
Okay, so coffee is made out of this fundamental. So you combine this, just like how coffee is made by combination of different stuff. Every matter, everything that you see is made out of elements or atoms or molecules and ions. Okay, so today we are going to study about what does matter made of. Okay, so in order to do that, we have to understand what is an atom, what is an element, and what is a molecules, and what is an ions. Okay. Now let's start with an atom. So let's look at this woman in the pictures. Can we classify this woman as a matter? Yes or no?
Um.
Is this woman a
Yes.
matter or not a matter? How do we define matter again? Matter is,
Of matter is anything that occupies
Anything
space.
that occupies space.
does this woman occupy a space?
Yes.
Yes. Where? Wherever she lives. If she
Yeah.
sleeps at home, she occupies a space at home, right? If she lives
Uh,
in, let's say, in Timor Leste, she occupies some space in Timor Leste. Okay. What about her hair? Does her hair also on a space? A matter? Obviously, her hair is
Yes.
occupies some
yeah.
space in her body.
Yeah.
Yeah.
So now my next question is, what do you think hair is made out of what? How would you say that? Just like coffee earlier, you say coffee is made out of coffee, water, sugar, and some milk. What about hair? What does hair made out of? What does anything made out of? Okay. Now let's go into that. Let's look at what is the hair made of. If you just look at like this, using your eyes, you can see
Yeah.
clearly that the person has a hair. But let's evaluate what is hair made of. Hare, for example, for tiane, kung imi leno basic, imi hare katak idanene, there's a bunch of hair. Yeah, fuk barbaraklos, fuk lahan barbaraklos. Let's just go look at the closer deeper. Let's look closer. So these are the hair strands. So each individual hair, you can definitely see that. Lost?
Yes. True.
Okay. Let's continue. Look at that. So this is about if each individual hair is about this, it's like this. So each individual hair, if you just look at it, that's about the 100 micrometer. So 100 micrometer is about, so 1 meter is how many? So if you have 1 meter, you can imagine 1 meter, right? You can see when something is 1 meter, you can see that it is, you can see, right? So if it's 100 micrometer, that simply means 100 times 10 to negative 6 or 1 times 10 to negative 8 meter. That simply means is 0.000000671. Do you know how small that is?
Ultra small.
They're very small, but you can still see it with your hand. You can still take it one strand of hair.
Yeah.
You can still see it even though it's very very small. Let's go dive into. If we go down more, what do you think is hair made of? Down you can see the cell of the hair cells.
Yeah.
So within that hair you have different cells. Okay, that cell is about 10 microns. So that's even smaller. That's like much more smaller. Yeah. So 10 microns now this becomes 10 microns, 10 to negative 6. It's much smaller. Okay. So earlier 100 microns. So that's 100 times 10 to negative 6 meter. Now this is only 10 microns, which is just 10 times 10 to negative 6 meter. So now you're getting closer, right? So if you go deeper, so this is the cell of the hair. If you go deeper, what the cell made of? Cell ni halos say that. What the cell made out of? Okay, so this is the hair. If you go deeper, you look at the hair cell, right? If you go down deeper again, haril yu tama tambalarang, cell ni halo husi, ema bolar microfibril. So now you have 1 microns. So this is a hair. This is the cell. Micrometer, yeah. And this is macrofibril. Macrofibril. If you go down again, now hair is made out of different microfibril. That's about 10 nanometer. Then you go 10 nanometer. So that is 10 times 10 to negative 9 meter. So negative 6, you go up to negative 9. So that's about 1 times 10 to negative 8 meter. Very, very, very small, yeah? That's microfibril. And then if you continue looking at that, macrofibril, and then you go down, you continue look at that, that's microfibril. So let's go down. Microfibril is made out of what? Now you can already see the protofibril. That's about 2.8 nanometer. If you go down again, now you can see the keratin molecule. Alessandra, pernah raw lift from keratin?
No.
Keratin is usually when there is a babayang biasa ko na promosi ko na ba sampo na ima temi halet keratin, yeah. So keratin is a molecule now. Now keratin is made out of what? That's about 2 nanometer. That's about 2 times 10 to negative 9 nanometer. So if you go down again, keratin now is made out of what? It's made out of different elements. You have element carbon, you have oxygen, you have nitrogen, and you have sulfur. Okay? So keratin is made out of different elements. But so what does elements made of? Element, how do you say that? Element is made out of, let's say you take a carbon element. Okay, so in the carbon element, you have and then we call an electron orbital. When you look at here, this thing over here that you see, this thing over here, the blue, this is what you call an electron orbital. This is where the electron moves around. Okay, but if you go deeper, now the element is made out of a nucleus. This is the nucleus. Can you see the lighting here?
Yes, sure.
So this is what you call a nucleus. So inside that nucleus is made out of, so this is why chemistry is very, very important and very, very, it's the fundamental sciences, because you study matter from the something that is from Hosibe, Husi nucleus maximi. Earlier you see a woman with the hair, and then you look deeper into the hair. Hair is made out of what? A cell. And then you look deeper, the cell is made out of macrofibril. You go look deeper, macrofibril is made out of what? Made out of microfibril. You go down again, microfibril is made out of protofibril. You go down again, and protofibril is made out of different elements, like keratin. And then elements, they are made out of molecules. And you go down again, molecules is made out of elements, different elements. You have carbon, sulfur, oxygen, right? And then you go down, and what is elements made of? Elements made out of what? Made out of this nucleus and nucleus and protons and neutrons. So you see here, this is the carbon atom where you have the proton is the red one and the neutron is the white one. So in the nucleus, nucleus you have two things. What is in the nucleus? Nucleus you have proton and you have neutrons. Okay. So this is what protons and neutrons are. So can you understand what that is? An atom. So atom is consisting of protons, neutrons, and electrons. That's an atom. Comprende?
Yes, sure.
So what is an atom? Atom is the smallest measure, the smallest makeup of things. So just imagine ito ni analogy of coffee, kafe ni, lo sala. Imi diyan kafe ni halos si seda. Say mi harede, kafe ni halos si kafe, mas midar, be hota, susubeng, lo sala.
Yes.
Yes, sure.
Usa analogia ito ne, ito aplica faliba materia hoto to all matters is made out of atoms. Everything you see, even yourself, the medicine you take, the water you drink, yeah, the food that you eat, everything is made out of an atom.
Atoms.
Okay, atom comes together, forms an element. Element comes together, makes up a molecule. Molecule comes together and form a substance or material, a matter. Okay. So what exactly is an atom? An atom is what? So earlier you see the middle inside here is what you call the nucleus.
Atom. A nucleus.
No, the whole thing, this whole thing is an atom, but within an atom, it composes of nucleus in the middle. Within that nucleus, you have two things. What? Protons and neutrons. And then you have an electron that's floating around in the shell like this. That's the path of the movement of electrons. ¿Todavía comprende?
Yes.
So in the
Yes,
middle,
sure.
you have, in the middle is what you call what?
Nucleus.
Inside the nucleus, you have what?
Protons and neutrons.
Protons and neutrons.
Yes.
And then what is surrounding protons and what is surrounding nucleus? Electrons.
Electrons.
Electron is what is surrounding a nucleus. So if I ask, what is an atom? Your answer is the smallest units of an element. That's the very smaller one. So an atom consists of what? The central nucleus. The atom has a central nucleus surrounded by one or more what? Electrons. ¿Todavía comprende ya? So an atom has a nucleus surrounded by one or more electrons. So if you look at here, look at this video over here. So this is how an atom usually looks like. Can you see the video? So the middle, the center there is your nucleus, and electrons is usually moving around like this around a nucleus. Later on, we will study every element. The identity of every element is determined by how much proton you have, as well as how much proton you have. And then the number of electrons that moving around here determines how much charge, what it's your ions is. Can you see that? This movement over here, Imhareta? You guys see this, right? Imhareta?
Yes, teacher.
Yes, teacher.
In the middle there is your nucleus, and within that nucleus you have protons and neutrons, and then you have electrons moving around its orbital. Okay. So orbital is basically just like the sun, like ito na loromata na ito. So this is the Earth. Earth is moved around an orbit of a sun. So 1 year. So this is starting zero. So this is start. This is how you measure time. So when the Earth rotates around and then it comes back into the initial position, that is 1 year, or it's equal to 365 days. That's how you measure the years and times. Comprende? Imagínate, no hay de Did you
Yes,
know that? Did you know about
yes.
the Earth rotate around the sun? One full revolution is equal to 1 year. So this is the orbit. This is what you call an orbit. Yeah. So just like the Earth rotates around the sun, electron rotates around around what?
Nucleus.
Nucleus. Correct. Electron rotates around a nucleus. Okay. Just like this. Now the question becomes, what is a nucleus? You already know, right? Nucleus is what? Nucleus is nucleus is the central part of an atom. It is in the center. Nucleus is composed of what? Composed of two things: protons and
Newton.
neutrons.
Neutrons.
Okay. In the atom. Now my question becomes, the mass of an atom, what ilan niya and the mass of an atom, almost all mass of an atom is contained within the nucleus, not the electron. Electron also has a mass, but contribute very, very little to the overall mass of an atom. Okay? So now you understand what is a nucleus. Nucleus is a central part of an
Part of
atom.
the outer atom.
A nucleus is composed of protons and neutrons. Nucleus contains most of the atom's mass. Okay? Now that you understand that, you understand what is a nucleus. Now let's understand what is a proton. Now, what is a proton? So proton is a positively charged particles. A proton is a particle that has a charge of positive. Okay, so the scientists have determined that within the proton, you have a charge, or in English, Portuguese, carga. Remember, a proton has a charge of positive. Remember that. Don't forget that. Proton is positive. Where do you find proton? Proton is where? In
The
Nucleus.
nucleus. You find proton in the nucleus, or atomic nucleus is what we call it. That is a proton. What about the neutron? What is a neutron? Neutron is zero charge. There is no charge. Where proton is positive charge, neutron is uncharged particle, meaning it does not have a charge. Okay, neutron, no charge. Where do you find neutron? You also find neutron in the
nucleus.
nucleus as well. Okay, so now you understand. Proton is positive charge. Neutron is no charge or zero charge. Both proton and neutron is found in nucleus. Okay. What is an electron then? An electron is a particle with a negative charge or negatively charged particles. Okay, so the only thing between proton, neutrons, and electrons, proton is positive, electron is negative. Neutron is no charge.
No charge.
Okay, but protons and neutrons located in the nucleus, and electron is moving surrounding that nucleus. And where does electron located? Located around the shell, or surrounds it, around the shell, around the nucleus, around the atom's nucleus. So that's where all electrons. So you have a nucleus over here, and then your electron will move around in some specific orbit. We will learn about orbital theory, orbits later. But that's the point. Any questions so far? Preguntas?
Yeah, I have, teacher.
Yes, go ahead.
I want to ask, I who sila ni teacher ni tama ho to ba iha atoms kalay tamo yung teacher
Yes,
din.
yes, everything. I whom. Remember how do you define matter? Anything that occupy
Space.
space. I whom ocupa espacio rumagala.
Yes.
Yes. Tama I whom ocupa espacio. Yes. Niemos matter hot. I who said nemos halo husi. Halo husi sera. I tani ya chlorophyll. Chlorophyll is a molecule. So molecule is made out of an atom. Okay, let's go. Let's go look at that actually. If you, we can go and look at that if you want. Okay, so if let's say if we okay, so let's see. Suppose we look at the okay. Can you see my screen? Okay, so what does elemental composition of a tree? Let's say elemental what does tree made of chemically? What does tree made of chemically? Okay, tree is made out of what? Made out of cellulose, hemicellulose, and lignin, along with smaller amount of organic compounds, minerals, and water. Okay, tree is made out of cellulose and hemicellulose, yeah? Cellulose is a molecule. So if you look at this tree over here, physical classification of a tree. That's the heart of the wood. That's the sapwood. That's the vascular living form. And then if you look down into molecules, you have alpha, pinene, yeah, sunlight, carbon dioxide, water, sugar, and oxygen. Let's look at the chemical structure of a cellulose. So tree is made out of what? Cellulose or hemicellulose and lignin. Let's look at the chemical structure of cellulose.
Yeah.
Yes.
Chemical structure of cellulose. What is cellulose? So cellulose is just a molecule. It's an organic molecule. It's just a molecule. This is the structure of the cellulose. You have oxygen, you have hydrogen. This oxygen atom, hydrogen atom, and then they bond it, make a benzene ring over here. Okay, this is a cellulose. It's a much complex molecule, but same principle. It's made out of different atoms of or elements. Right? It's made out of carbon element. You have hydrogen element. You have oxygen, and etc. Now we learn later how do you separate one atom different from another atom. Okay, so yeah, everything is made out of. Let's say, what about rice? What is chemical formula for rice? What does rice made of? Rice ni halos isa chemically. I think it's carbohydrates. Carbohydrates, specifically amylose and amylopectin or proteins. You have fats, fibers, and minerals. Let's say look at this specifically amylose carbohydrates. So this is amylose. Amylose is a very specific long chain hydrocarbon like this. This is rice. Sometimes you also have different polysaccharides. Yeah, amylose, glycogen. So these are all chemical molecules, yeah? It's basically hydrocarbons made of carbon, hydrogen, and oxygen. So most of organic matter, rice and trees, we classify it as an organic materials, organic matter. Like metals, classification as an inorganic matter. So generally in chemistry, you have organic chemistry, where you study about organic matter, and you have inorganic chemistry, where you study about when you study about steel, metals, irons, zinc, cement. Comprende?
Yes, teacher.
Yes.
Okay, so yes. To answer the question is yes. That is the. So let's go back to that. All right. So now you understand what? Now you understand two things. Chemistry is the science that study about matter and the changes that matter undergoes. We define matter as anything that occupies space, and we now understand matter is made out of what? Made out of an atom. An atom is made out of a nucleus and an electrons. Within in nucleus is made out of protons and neutrons, and surrounded by an electrons. Together they call an atom. Comprende?
Yes, sir.
Yes.
Okay, that's what an atom is. So if I ask what is an atom is a particle that has a nucleus and an electron. Or you can say a particle that an atom is the smallest unit of matter that composes of protons, neutrons, and electrons. That's basically what an atom is. All right. Any more questions?
None, teacher.
No, teacher.
Now let's look at now that you understand what is an atom, now let's understand what is an element. So you understand an atom now. Now let's understand what is an element is. So all elements are composed of atoms. Yeah, every element is, so for example, hydrogen is an element, oxygen is an element, yeah, carbon is an element, iron, magnesium, that's all an element, yeah. But at the earlier science, yeah, beginning, nene, nobody can see an atom. Do you guys think can we see an atom? What do you guys think?
No, we can't not see an
Why?
atom.
Because it's very, very small. It's like 1 times 10 to negative 9. That's like 0.000000001, 2, 3, 4, 5, 6, 7, 8, 1 meter. 9. That's very, very. Imagine how many zeros behind it. 9 zeros behind a one before you get a 1 meter. Do you have any idea how small that is? Really, really small. You cannot see it with your eyes. So over the years, scientists have proposed different models of an atom. So one person says, "Oh, I think this is how an atom looks like," but nobody knows for certain, yeah? Remember, lahi ema idam hatene 100%. Sira halo proposal kata ko hatu hani atom ni harian sane. Favan, you understand tetun, yeah?
Yes, sir.
Okay. So atom ni harian sane. Right? So the first atomic theory model was proposed by an English chemist. We call him John Dalton in 1803. This is his picture over here. He was the first guy proposes that, oh, I think atom is looking like this. Okay, so he said all elements are composed of atoms. That simply means all elements are made out of atoms. Okay, and then over the years, so some scientists, so for example, J.J. Thomson discovers that in an atom, you have a negatively charged particles. Apparently, they conduct an experiment. I don't want to go into detail how they do it. You probably will not understand it better. But just so you know, how do you know that the question becomes, so how do you know that an atom has a negative charge or positive charge, or there is no charge? How do you know that? Right? So scientists conducted an experiment, specifically J.J. Thomson. He conducted an experiment that within an atom, there is a negatively charged particles. Because today we know it as an electron, but earlier in the days, during the 1890s, nobody knows about an atom. During the 1800s, nobody knows that atom is made out of electrons, protons, and neutrons. Today we know, but earlier we don't know. People don't know that. Emang latihan ini ya 1800 ni emang latihan ni atom ni halus saya dah. Agora kita latihan orang tambah tempo progreso ba oy. But earlier, J.J. Thomson discovered that within an atom we have a particle that have a negative charge particles, and he called that an electron. And at the same time, Ernest Rutherford also discovers nucleus. He discovers that nucleus, that we also have a protons and neutrons. So J.J. Thomson discovers electrons with negative charge particles. Ernest Rutherford, I think he's a New Zealander, he discovers a nucleus. And he said, nucleus has a protons and a neutrons, where protons is positively charged particles. And then in 1913, Niels Bohr says that, now that we understand what a nucleus is, what an electron says, proposes that electrons orbits or energy levels around the nucleus, meaning electron is moving around a nucleus. That's in 1913, just like over less than 100 years ago. Over 100 years ago. A little over 100 years ago, yeah? So we didn't. So we already know about we already know about electrons, neutrons, and protons for over 100 years. So we pretty much understand what matters is. So each of these guys came up with different models of what they think an atom will look like. Yeah. Over the years, people have came up with different models. So J.J. Thomson, atomic model, he models an atom based on this. Like his model is based on uh, like a pudding where you have a negative. He said this is an electron. This is a pudding. If you see a chocolate, this is a pudding. Where within that is he used an analogy like this. So your electron is this chocolate plums, and the positive charge is this. That's according to J.J. Thomson. Yeah. So basically, what he says is that you have a negative electrons, and then you have positive filling in the gaps. That's what J.J. Thomson says. But that's not really accurate model of representation. And then the Rutherford's model of atom is more. It's a little bit better than J.J. Thomson says. Rutherford is saying that you have a nucleus consists of a protons and a neutrons is this one, and then orbits around that is an electron. So this blue electron is moving around in an orbit. That's according to Rutherford. So that's also not good until the Niels Bohr comes out and so yes, I agree with what Rutherford is saying, but what I'm saying is that the electron that moves around a nucleus has different levels of energy. So for example, if you have two electrons that move in this one energy level, only in this circle, and there is some electrons will move at much higher circle like this. So this is level 1, level 2. So Rutherford is saying, earlier Rutherford simply says that Rutherford and the katak electron na halay hadulas nucleus na but does not specify different levels of energy, different levels of how electrons is moving. Now comes in, Niels Bohr says that, oh, electrons is moving around a nucleus at different energy levels. Okay? Any questions so far?
None.
I want to emphasize, yeah, this is only a model, meaning according to each scientist, what they think an atom looks like. Okay? So much year later, now that we understand, now using quantum mechanics, yeah, mechanical quantum, scientists either they came up with a model they call it Schrodinger's atomic model. So basically, it's based on a probabilistic set. Is that if you have a nucleus over here, this is an atomic nucleus. So probability of finding an electron is this region. Probability of finding an electron. We call it atomic orbitals. So basically, it's like what is the likelihood where you find an electron? Instead of saying something that I know for sure that electrons will be there, no. What they're proposing is that with probability, I know that around 90% you will find an electron in this region. That's what they say. I know with 80% that you will find an electron in this region. Comprende? So that is the more accurate description of atomic model is. Using quantum mechanics, they're saying that yes, they support the idea that a nucleus is at the center. They also support the idea the electron is moving around a nucleus at different energy levels. But the exact position of an electron is probabilistic, meaning it's a probability where you might find an electron. You cannot say that, oh, I'm 100% sure that electron is surrounding here. So they came up with a probabilistic model. That's why you have different orbitals. Different orbitals. For example, if you see here, we'll study more later about orbitals later, but you have an s orbital, you have p orbital, d orbital, and f orbital. We will evaluate each one of these later on down the line. But the point is, you have a nucleus that surrounds an electrons, and Schrodinger is saying the s orbital is the probability where you might find an electron. Okay, remember that. Okay, so how many models started with who? The first guy, John Dalton, proposes it, and then J.J. Thomson discovers an electron, gives his atomic model. Rutherford discovered protons and neutrons on nucleus, gives his atomic model. Niels Bohr gives his model, and then we ended up with Schrodinger's atomic model. That is based on quantum mechanics. The closest models, the closest atomic model in modern times, modern. So every day, if you go to take science, sekarang imi forty science, imi student ciencia. Now my question becomes, why do you think this is important for you guys as an architect? Why do you think it's important to know an elements or chemistry for an architect?
For building materials.
Yes, for materials. Different building materials. If you want to came up with the new materials, right? If you want to invent the new kinds of materials that improve the quality of your buildings or the thing that you design, right? Terus correct? It is good to know the chemistry of it, so that la rumah imi le sekarang imi comprende ciencia, lo segala. Ni kan imi bele le different research about materials that you can understand. Lo segala. Sekarang kalau comprende zero con ba chemia, ole materia olebe pesquisa sira nebe relação descobrimento materia fone, you probably will not understand. Do you agree?
Yes.
Well,
Yes.
so as an architect, chemistry is useful in that way. So down the line, abang by dua kali imi benar-benar focus duni. Like an architect is not just simply designing a house, making it look aesthetically beautiful. Yes, it is a big part of an architect's job. Yes, my babe, it is also better if you came up with much cheaper materials, readily available material. That will be better. They call it sustainable design. Or if you have that knowledge, that will be better. That's how people get famous. All right. So that's so in conclusion, John Dalton proposes like this, that an atom is made of big spherical thing. J.J. Thomson proposes that an atom is like a black pudding model, where you have a positive and negative close to each other, like a pudding or like a cookie, chocolate chip cookies. And then Ernest Rutherford is like, no, actually the nucleus is in the middle, and then electron is surrounding. And then Niels Bohr proposed that an electron is a nucleus in the middle, electron moves around, but a different energy level. And Erwin Schrödinger comes in and say, yes, in 1926, it takes about from 13 to 30, so about 13 years. This is 13 years. Then we have the closest to the reality. That's using quantum mechanics. Yung panaroon na be, quantum mechanics, have you ever heard of this? In a TV
Yes.
somewhere?
Yes.
Have you studied it?
Not yet.
Yeah, it's very difficult. The good thing about the difficult thing about quantum mechanics is it's very difficult to understand it. The good thing is nobody understand it. Very difficult. Like when you go to take these classes, I don't think take a class, that I just sit and listen and read about it. They say that the good thing about the bad thing about quantum mechanics is that very difficult to understand. The good thing is nobody understands it, even the most famous scientists who came up with it. So, yeah. So 13 years, and then we develop the much closer one. So it says that an electrons, so saying the probability of finding an electron is this. Later on, I'll show you a video what that means. Yeah. So in conclusion, atomic parts is made of protons is what? Positive, some mass, is located where? In nucleus. Neutrons is no charge, with some mass and also located in nucleus. Electrons is negative. Electron has no real mass, but do take up most of the space around an atom. So an atom, if you look at the mass, most of the mass of an atom is located where? In the nucleus.
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 Electron is essentially no mass, no real mass. But proton is positive, and neutrons is zero charge, electrons is negative. Okay, up to this point, comprende, yeah? Understand, yeah?
Yes, sir.
Okay, we only have about 30 minutes left before class ending, right?
Yeah.
So what is the properties of an atom? So basically, if you look at the periodic table, people are usually divide an atom by like this. So if you have there's like a small box over here. If you look at the letter C, that is the symbol for carbon. This number over here represents atomic number. Atomic number is how much protons does carbon have. So carbon has 6 protons. Okay, that's why it has a 6 protons. And then usually you have 12 like this, is indicating the mass of that carbon atom. That's how atoms are being classified. So every time you see this, so the symbol, the name is carbon, the symbol is C, the number, the atomic number is 6. This 6 is representing what? The number of?
Protons.
A number of protons. So the identity of an element, atom, or the identity of an atom or an element is determined by the number of what?
Number of
number of?
protons.
The number of protons. So if you have 6 protons, you have to put a name into it. That's carbon. If you have 7 protons, that's a different name. If you have an 8 proton, that's a different name, right? If you have 9 protons, that's different name. Understand, yeah?
Yes.
So an identity of an element is defined by how many protons does it have. Okay, that is how you define an element. So basically, an element is this. An element are pure substance made of only one type of an atom. Yeah, an atom is made of protons, neutrons, and electrons. So, for example, if you have an atom, the carbon atom has 6 protons. Earlier, I said the identity of an element is defined by the number of protons. So, for example, if you have number of protons, that is the name of that atom is carbon atom. Now, if you have the number of proton is, let's say, 11, like this, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you cannot call that carbon anymore. Why? Why can we not call it carbon anymore? Because the number of proton is changing. Carbon only has 6 protons, while 11 protons, you have to call it different name. What do we call it? We call it sodium atom.
Sodium.
Yes. So today, up to today, we have a total of 100 different elements that have been discovered so far. And this is what you call a periodic tables of elements. Okay, so if you look at carbon over here, this 6 is representing how many? Representing what?
The atomic number.
Atomic number or the number of? Number of protons.
Or protons.
So if you have 6 protons, you call that a carbon. What if you only have 5 protons? What do you call that?
Carbon.
Boron.
That's a boron. What if you
Boron.
have 13 protons? What do you call that? That's a?
The aluminum.
Aluminum, yes. So if you have, let's say,
Aluminium.
8 protons, what element do you call that?
Oxygen.
Oxygen, yeah. Or for example, if you have 55 protons,
Oxygen.
you call that cesium.
Cesium.
Or for example, if you have one proton only, you call that
Hydrogen.
hydrogen, yeah? Or for example, if you have, where is uranium?
I
I want to see uranium. Uranium is a high molecule. Yeah. If you have 92 proton, you call that uranium.
Uranium.
Thorium. These are all the elements that people use nuclear bombs with, yeah? Cesium, uranium, thorium, plutonium. Those are most of the elements that people use to make nuclear weapons with, yeah?
uranium.
Okay, so that's the periodic tables of element. That's an element. Let's do probably a simulation. I want to do a simulation actually.
Teacher,
Yes.
can teacher send the period of element so we can copy?
Yeah. You will print it.
Print.
Yes, I will send it. All right. Can you see this
Thank you.
model over here? Can you see the screen?
Yes. Yes, sir.
Building a nuclear chart intro. Which one? I don't know.
Yes.
All right. I think not this one. Not this. Built a nucleus about teaching resources. Nope. The other one. Okay. If I have one proton and one neutron, that's still hydrogen, right? So you have
Yes.
one proton, that's just hydrogen. So proton is with this. The electron cloud. If I add more neutrons, does it change the identity? No. It doesn't change, right? But if I add another protons, it changes the identity to helium now.
Helium.
I can add many neutrons in there, but it doesn't change the identity. It's still helium. But I add one proton, now it becomes lithium. One more, it becomes beryllium. One more, it becomes boron. One more, it becomes carbon. One more, it becomes nitrogen.
Nitrogen.
One more, it becomes oxygen. I add this, that becomes an oxygen. And electron cloud, that's where the electron is. So if I take out the electron cloud, this is what it is. Okay? So for example, if I put a neutron over here, that's one hydrogen, one neutron. That's helium. So that's the different elements. Yeah. So basically, that's what the nuclear. That's what an atom looks like. All right. Any questions so far?
None, teacher.
No, teacher.
All right. So I want you to next time in class, I want you to print a periodic table and then bring it with you every time you come to class. Yeah. Let me see if I have something here. Yes, this is the periodic table. So this is the periodic table. Please print it. So bring it with you. Make it print it bigger. Yeah. Maybe bring it big ito. Ang pot ito na bile kikuha ni pa rin lemos. I just send it to the class over there. So maybe print it because we will be using it every time we have a class. Okay. Mihari na to kirimban.
Yes, sir.
Periodic table of elements.
Yeah.
Make sure you print it and then bring it to class. All right. Now that you understand what is an atom, what is an element, so element is just a different number of protons that an atom have, right? If you have six protons, that's a carbon. If you have a 10, That's a neon. If you have 11, that's a sodium. 11 protons, that's sodium. You have 19 proton, that's a potassium. I memorize. I've been doing chemistry my whole life, so I memorized some of this stuff already. So, do you guys know what my background of study is? Mihatene?
No, teacher.
So I did my Bachelor of Science in, I have BS in Chemical Engineering.
Oh.
I have MS, Master in Chemical Engineering. And I also have right now I'm doing a PhD in Chemical Engineering. Okay, so all my bachelor's, master's, and PhD are all in chemical engineering. So it's so that is why every time los gala imi pernah ron de estudio kimia ni susah los.
Yes, teacher.
Do you know why?
Because
Tamba because you study about atoms. So estudio ako na buat nebe o lapel hari matang. Jadi o tenki he imagina sangue de nebe dia foi bele comprende conceito ida. De química. Okay, but if comprende the idea, if you understand the fundamentals well, the rest is just a matter of playing with it. So if you understand the fundamental like atom ni sa ida, ni karga ni sa ida, electrons ni lawin sa, which you already learned about this, that we already talked about that. All right, now, so today we are going to talk about the atomic mass, the mass, just like any other thing, just like Favanio has a mass or Alessandra has a mass. Okay, once again, Favani, what is your mass? Favani, what is your weight? How do you answer that?
600
Newtons. Yes, very good. Yeah, 600 newtons.
Yeah.
Now, when people ask about weight, your answer should be in newtons. When people asking about what is your mass, that's when your answer is in kilograms. Okay, don't confuse that. Okay, so 60 kilograms is your mass, 600 newtons is your weight. Just like any matter, atom also has a mass. We call it an atomic mass, and the units for that is we usually call it AMU or atomic mass unit. So basically, 1 AMU is equal to 1 times 1.66054 times 10 to negative 24. That's a very, very, very small mass. Yeah. So imagine 1 kilo or 1 kilogram is equal to 1,000 gram. That's for regular humans. So Favanio is 70 kilograms. So that means his weight is about 7,000 grams. Now, or 7 times 10 to the 4th gram. Now, the mass of an atom is 1.66054 times 10 to negative 24 gram. That is 0.000 until 23 zeros, and then you have 24. That's very, very small, yeah? So 23 zeros before the number 2 and 4. So 10 to negative 24. So that means very, very small mass. But regardless, we also study that. So the unit for measuring a mass of an atom is what? What unit do we use?
AMU.
That signifies what? Atomic mass. Atomic
Unit.
mass unit. That's a unit specifically for the mass of an atom. Okay, where 1 AMU is equals to this. Don't forget. So if I say 2 AMU, that simply means 2 AMU, it simply means 2 times this number. 1.666 as 0.54 times 10 to negative 24. That grams. If you want to convert that to grams, that's how you usually convert it. Yeah, remember that. So that's AMU. Atomic mass sometimes also called atomic weight. Sometimes people call atomic weight. Sometimes people also call average atomic mass. Or sometimes people also call relative atomic mass, regardless, yeah? Now, let's talk about an isotopes, yeah? So carbon, usually in nature, yeah? Iyan natureza, nene? So when I said earlier, what define an identity of an element? What define an identity of an element? Number of what?
Protons.
Number of protons defines the identity of an element, right? Where does protons
Yeah.
located?
Neutron. No, nucleus.
Nucleus. So inside so you have a nucleus over here. So let's just make a big circles. You say that this is where you find I want to use different colors, okay? Let's say this is let's make the circle of this. Okay, and then inside that you have obviously a carbon atom has 6 protons. You see 6 red dots, and you also have different. So the carbon atom also has different isotopes. Isotopes means they have different in nature. Yan natureza nene. People often use what is going on? All right, so you have 1, 2, 3, 4, 5, 6 also. That's the neutron. Neutrons is in blue, protons is in red. Okay, the number of protons does not change. That is the identity for carbon, right? But sometimes in nature, carbon has two isotopes, meaning it can also have neutrons, has a number of neutrons is isotope 1. Isotope idafali makanya carbon 12. You have neutrons is how many number of neutrons? Hold on, number of neutrons. If you have number of neutrons is 12, we call it carbon 12 because 6 protons plus 6 neutrons. Sorry, number of neutrons is 6. If the number of neutrons is 7, we call that carbon 13. That's why we call it an isotope. Isotope is the same element but different number of neutrons. Comprende? Same element with different number of what? Of
Newton.
Okay. Okay. Ihan natureza, ihan mundo nene. Barakliu, carbon nebe emahetan barakliu, 98,89% nene. Carbon 12. Mostly. About 98.89% are carbon 12. The rest is carbon 13. A carbon with an extra neutrons. Comprende? Então,
Yes, sir.
então, sama ita to determine ini atomic mass unit ba carbon. Berarti ni 98 kali ba 12. So that's with 0.9889. That's the percentage. Multiply by 12. Carbon 12. You plus 1%, 0.0111% times 13. So carbon 13, you divided that by. So that is equal to 12.011 AMU. And that is what usually represented in at a periodic table. So like this, look at carbon, 12.00001, 12.01. That is the AMU of carbon. AMU of oxygen is this, 15.9999. That's oxygen. For helium is this, chlorine is this. So every number in here, that is already calculated on that's already calculated AMU of each element. Okay. So for example, carbon is 0.0078. That already taken into account different isotopes of that element. Comprende?
Yes, sir.
Yes.
So what is an isotope again? Isotope is the same element with different number of
Neutrons.
neutrons. So carbon 13 has an extra 1 neutron. The number of protons doesn't change, still 6, but 1 added extra neutrons. So we call it carbon 13. Mostly, yeah. But in nature, most of the carbons, 98.89% are carbon 12. Any questions so far?
None, teacher.
Okay. So now that you understand an element, now let's understand what is a molecule. So molecule is the smallest particle. So when you have two elements combined together, two or more elements combined together, you make a molecule. Okay, so element is like this, only one like this. Periodic table is an element, periodic table of different elements, yeah? So when different elements come together, make a bonding or react together, they make a molecules.
Molecule.
So for example, if you have two nitrogen together, they make nitrogen gas. When you have two oxygen together, they make oxygen gas. So together, nitrogen and oxygen is what usually you breathe. This is the air that you breathe. So 21% is oxygen, 79% is nitrogen. That's the air. Usually you breathe air, right? The air that you breathe is usually this percentage. It's a combination of nitrogen and oxygen molecule. Or for example, if you have two carbons combined together, two oxygen combined with one carbon, that is together make a molecule that we call carbon dioxide. Usually when ini kuliah ko na babe, sera global warming ga nene, emay dene ne temilet ni nana ko sala CO2, carbon dioxide nero sala. Imiron hali. Have you ever heard about that? Imiron na be ka dioxide of carbono sidak.
Yeah.
Which one, teacher?
Carbon dioxide.
Already heard about that one, teacher.
Yeah, usually when they talk about global warming, sala kung mudansa klimatiko, biasa idane ma be sera CO2 malur sa sarang hilit, kana sa sarang hilit. Okay, or for example, if you have two hydrogen combined, you make hydrogen gas, or you have, let's say, water is combination of two hydrogen atom and one oxygen atom. That's why you call H2O. We call it water, the water that you drink, the water that you cook, the water that you wash your clothes with. Okay, so the water is how many hydrogen atoms in water? How many hydrogens are in water? How many hydrogen? Look at here. Look at two hydrogen.
There's two hydrogen.
Two hydrogen and one
oxygen.
Oxygen together.
Oxygen.
So this is what you call a molecule.
Molecule.
Molecules is made out of different elements. You have element hydrogen, element oxygen, but you have two hydrogen elements, one oxygen. So different each. So this is an atom, oxygen atom, hydrogen atom, or hydrogen element. Together they form a molecule. So comprende, no? Diferente entre elements and molecules.
Yes, sir.
Yes, sir.
All right. Now that you understand elements and molecules, so the molecules divided into what we call a monoatomic molecules. So meaning molecules that only has one atom. For example, argon is monoatomic because it's only made out of one argon only. Or helium, that's a monoatomic molecules. It doesn't make up of any other. Okay, diatomic molecule is where you have two oxygen. So O2 is made out of two oxygen and oxygen bonded. Or hydrogen, that's two hydrogen gas. You make, that's what we call a diatomic molecules. If you have, let's say, four, we call it tetraatomic. If you have three, let's say like water, that's no, yes, that's diatomic molecule still. Okay. So different. So di means two, tetra means four, poly means many, mono means one. That's Latin words. Yeah. All right. So example of the molecules of compounds are this: water, ammonia, carbon dioxide, hydrochloric acid, sulfuric acid. Yeah. Where do you find this? Where do you think you find this? Sulfuric acid in bukan na. I think you know it in everyday life. Akibeng, akibeng. Haten ito akin niya beng.
Yes,
Nembel fakar bim ni limang alay.
labene.
No, don't do that. Okay, it will burn your finger, your skin, because it has a sulfuric acid. It has a positive charge and an SO4 negative 2. This is an atomic. This is a this is an ionic bonding that will burn your fingers, your skin. So don't ever do
Teachers,
that.
teachers, but sometimes ema quando kanek ainda da rumah hau ema dia bele fakat akibemba.
No, 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 don't do that. That's a bad idea.
Yeah.
Depende akibenda na be, akibenda o dihane daruma keta kira kare ida be ne kare. If you have like sulfuric acid akibend, then don't do it. Okay, and then ions. What is an ion? So you have okay. Let's understand this from a perspective of like this. Let's say so boron. Boron is how many protons? Boron has a. So let's say boron has. Boron has 5 protons. Yeah, 1, 2, 3, 4. That's 5 protons. And you have 5 neutrons. So that's a boron, right? And then obviously you have a electrons that moves around in a like this. Electrons move around in an orbit. Yeah. That's electrons. Okay. Different energy levels. You have this. Electrons, 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 electrons. Oh, you only have 5. So 1, 2, 3, 4, 5. So that's neutral charge, yeah. So how many protons does a boron atom have? So this is a boron atom, yeah. This is a boron atom. This is boron atoms. How many protons does an electron, does a boron atom have, or boron? How many protons?
5.
5. So
Five.
number of protons is, number of protons is 5. So protons is, in the chart side, the protons is what? Positive or negative?
Protons is
Positive.
positive.
Number of protons is 5. So if you have positive 5, that means you have 5 positive, right?
Yes.
How many electrons does it has? It also have 5 electrons. So that means you have 5 electrons. So you have 5 positive with 5 negative. When you sum them up, you get what? You get 0,
2.
right?
Yeah.
When you in this case, we call it a neutral atom. Now, what happens if I remove one of the electron? Instead of 4, now I get 4 negative. What will happen to this? The
Will
boron
change.
atom will become 5 positive plus 4 negative becomes
If
positive 1.
plus,
Becomes boron like this. That is an ion. So an ion is basically that. So basically, if you have more protons, then that is positive ion. If you have more electrons, that is a negative ions. So positive ion, we call that a cation. So cation means you have a lot of protons available. That means you give up electrons already, meaning you sekarang ohasaite electrons ida. If you give up electrons, what do you have here? So if you give up 3 electrons, what is the charge? This will become what? Now, if you give up 3 electrons, what is this boron will become? How many positive do you have? You have 5 positive plus how many electrons do you have?
5
Two.
or 2.
No, 2 negative.
Or 2.
5 positive plus 2 negative, you get 3
3.
3 positive.
3 positive.
Yeah.
So that is an ion. Because it's a 3 positive, this is cation or anion?
Cation.
Cation, because it is a positive. So when you give out electrons, earlier in a neutral charge, you have 3 electrons, right? Right? So when this is the case, this is 0. But when you give off electron, when you give out electrons, it becomes positive 3. All right. So for example, if you receive an electron, if you have a positive like this, yeah. Let's say if you have a chlorine atom instead of this, we'll have a chlorine atom. So chlorine. Oh, chlorine is maybe too big. Let's say a hydrogen atom. The hydrogen is 1 protons and then 1 neutron. Okay, and then you have 1 electrons over here. You have 1 electrons over here. So when you receive, so this one has no or another orbital. This one's none. So right now, this is the hydrogen atom, right? This is hydrogen with the symbol of H. So right now, how many positive do you have? 1 positive, yeah?
1, yeah.
How
1
many
positive.
negative do you have? 1 negative.
1 negative.
When together, that's a neutral charge. There's no ion. But what happens if you add an extra, you receive another extra electrons? Huh? What happens if you receive another extra electrons? Now you become 2 negative, 1
2
positive.
negative.
So together you will make 1 negative, right?
Yes.
Yeah.
So that is negative charge. So that's a negative charge. When it is a negative charge, meaning you have more electrons than you receive more electrons. Remember, yeah, you donate electrons. That means you give out negative. You left with more positive. When you receive more electrons, meaning you get more negative. That means it becomes become more negative, right? So when you have a negative ions, we call it an
Anion.
ion. When it is a negative ion, meaning it gained electron, okay? It loses the electron, lost electrons, gain electrons. So lost electrons is cation, gain electron is anion. Don't forget that. Okay. Sometimes ions is made out of 1 single atom also, but sometimes ion is also made out of different atoms, polyatomic atoms. For example, OH negative. That is, later on we'll discuss why the OH is negative later down the line when we talk about the bondings, why things wants to bond together. But that's what an ions is. Basically, ions is you have charge, positive charge is cation, negative charge is anion. Cation lost electrons, anion gain electrons. But don't forget that, okay? Any questions?
None, teacher.
All right, so that's it for today's class. That's our chemistry class for today, and I hope you understand now what is an atom. Now you understand what is an element. Now you understand what is a molecule, and now you understand what is an
Ion.
ion. Okay. So next meeting we will study more about how. If you understand this, so next meeting we will have also a quiz. Yeah. Okay, we will have a quiz next meeting, so make sure you study that. The video is already uploaded. So